Hello, 8th graders, and happy Thursday. Today we're going to talk about how to dilate a shape about a point. During this lesson, you're going to actually be drawing dilations when we know the center of dilation and the scale factor. Let's start with our do now. Look at the first question. Rectangle FGHJ, shown below, is translated 6 units right and 1 unit up to produce rectangle F'G', H'J'. Will F'G', be congruent to FGJH? How do you know? Yes, it is congruent. Remember that any image that is the result of rigid transformations, reflections, rotations, or translations is congruent to the original shape. So now let's look at number 2. Which statement about the side lengths of rectangle F'G', H'J' is true? The length of FG is 3, so the length of F'G' is also 3. The length of GH is 5, so the length of G'H' is also 5. A is correct. I know that B is incorrect because there are no sides with a length of 6, and I know that C and D are incorrect because there are no sides with a length of 9. So the correct answer is A. Now let's find some missing angles. The figure shows 2 parallel lines cut by a transversal. What are the unknown angles? Remember that vertical angles are congruent and angles on the same line are supplementary, or they add up to 180. Go ahead and find angles 2, 3, and 4 now. Angle 3 is a vertical angle to angle 1, so angle 3 is also equal to 75 degrees. Angle 2 is on the same line as angle 1, so they're supplementary. I can subtract 180 minus 75 degrees to find angle 2. Angle 2 is 105 degrees. That means angle 4 is also 105 degrees. Now let's use our knowledge of corresponding angles to find the measure of angles 5, 6, 7, and 8. What's the measure of angle 5, angle 6, angle 7, and angle 8? Angle 5 corresponds to angle 1, so it's also 75 degrees. Angle 6 corresponds to angle 2. It's also 105 degrees. Angle 7 corresponds to angle 3. It's also 75 degrees. And angle 8 corresponds to angle 4. It's also 105 degrees. Now let's look at the division problems on the bottom. 5 divided by 4. How would I write 5 divided by 4 as an improper fraction? It's 5 over 4. 1/5 divided by 4. To divide by 4, I can multiply by the reciprocal. Divided by 4 is the same as times 1/4. What's 1/5 times 1/4? It's 1 over 20. Now let's simplify some fractions. 3/15. What's the largest number that I can divide both 3 and 15 by? It's 3. When I divide both by 3, what's the resulting fraction in simplest form? It's 1/5. 8 over 24. What's the largest number that I can divide both 8 and 24 by? It's 8. When I divide both by 8, what's the resulting fraction in simplest form? It's 1/3. 15 over 10. What's the largest number that I can divide both 15 and 10 by? It's 5. When I divide both by 5, what's my fraction written in simplest form? It's 3/2. Now let's jump into today's lesson. Today we're going to draw dilations. Remember, a dilation creates a scaled copy of a figure. An image that is larger than the original with a scale factor greater than 1 creates an enlargement. An image that is smaller than the original is a reduction. The scale factor is the number that each side is multiplied by. And when drawing the dilation, the distance of each point in a figure from the center of dilation, underline center of dilation, is multiplied by the scale factor. All of the distances grow from the center of dilation. Let's look at an example. Draw the dilation of triangle ABC with a scale factor of 2 and a center of dilation C. That means that the sides are going to expand out from point C in straight lines. Before we can draw that dilation, we need to know the lengths of the sides in our original shape. What is the length of side AC? It's 2 units. What is the length of CB? It's 3 units. When I draw my dilation with the center of dilation C, those lines are going to expand along straight lines from point C. Now, if my scale factor is 2, I can find the length of AC in the new figure by multiplying 2 times 2. So what is the length of AC in the new figure, A prime, C prime? It's 4. If the length of CB is 3, I can multiply by 2 to find the length of C prime, B prime. What's the length of C prime, B prime? What's the length of CB in the new figure? It's 6. So to draw the dilation, I can count. AC will now be 1, 2, 3, 4 units. CB will now be 1, 2, 3, 4, 5, 6 units. And I can connect the dots of my new figure. Make sure that you're drawing this dilation on your paper. So now I have point A prime, point B prime, and point C prime. Point C doesn't move because it's the center of dilation. It's where the other points are expanding from. Let's look at another example. Draw the dilation of ABC with a scale factor of 3 and a center of dilation at A. This time everything will be expanding out from point A along straight lines. First, what's the original length of AC? It's 2. What's the original length of CB? It's 3. So what will the length of A prime, C prime be? What will be the length of AC in the new figure if the scale factor is 3? Well, 2 times 3 is 6. So A prime, C prime will be 6 units. What will be the length of CB in the new figure? Well, 3 times 3 is 9, so the length will be 9. So I know that AC is now going to be 6 units, and CB is going to go 9 units over from there. So I can label B prime and C prime and draw my triangle. Go ahead and draw that dilation on your paper now. The triangle was dilated by a scale factor of 3. Sometimes dilations will be reductions. Draw the dilation of ABC with a scale factor of 1/2 and a center of dilation at B. So here, our dilation is going to take place along straight lines from B to A and B to C. Because the scale factor is 1/2, it's going to get smaller. First, let's find the lengths of the original sides. What's the length of side AB? The length of side AB is 8. What's the length of side BC? The length of side BC is 12. To find the length of A prime, B prime, I need to multiply 8 times 1/2. Remember, times 1/2 means the same thing as divided by 2. What's 8 divided by 2? It's 4. So A prime B prime is going to be 4 units long. Let's draw our new point for A prime now, 4 units away from B. 1, 2, 3, 4 is point A prime. What will be the length of B prime C prime? Well, I need to multiply 12 times the scale factor of 1/2. That's the same as 12 divided by 2. What's 12 divided by 2? It's 6. So the length of B prime C prime is 6. I can draw the new point C 6 units away from B. 1, 2, 3, 4, 5, 6. Now I can connect my new points to make my new triangle. A prime, B prime, C prime has been dilated by a scale factor of 1/2. Each side is 1/2 the length of the original. Let's do another example. Draw the dilation of ABC with a scale factor of 1/4 and a center of dilation at B. First, we already know from the last example the original lengths of AB and BC. They're 8 and 12. If the scale factor is 1/4, what will be the new length of A prime, B prime? Well, 8 times 1/4 is the same as 8 divided by 4, so the new length will be 2. I can draw A prime 2 units away from B. Remember that B doesn't change because it's the center of dilation. So A prime is 2 units away from B. Draw that on your paper. What will be the length of B prime C prime? Well, I need to multiply 12 times my scale factor of 1/4. That's the same as 12 divided by 4, so B prime C prime will be 3 units long. Draw point C prime 3 units from B. Now I can connect my points to make my triangle. A prime, B prime, C prime has been dilated by a scale factor of 1/4. We may not always dilate from a center of dilation that's a point in the shape. Let's look at one more example. Draw the dilation of ABC with a center of dilation P and a scale factor of 2. So each point will be 2 times the distance from P on a straight line away from P. What is the original distance from P to A? It's 1 unit. What is the original distance from P to B? It's 1 unit. What is the original distance from P to C? It's 2 units. So, when I dilate the figure, if the scale factor is 2, what will be the distance from P to A prime? Well, 1 times 2 is 2. I can draw A prime 2 units away from P. What will be the distance from P to B prime? 1 times 2 is 2. I can draw B prime 2 units away from P. What will be the distance from P to C prime? 2 times 2 is 4. I can draw C prime 4 units away from point P. Now I can connect my points to make my new triangle. A prime, B prime, C prime has been dilated by a scale factor of 2. Now, draw the dilation of ABC with a center of dilation P and a scale factor of 3. First, What's the distance from P to A, the distance from P to B, and the distance from P to C? P is 1 unit from A, P is 1 unit from B, and P is 2 units from C. When I dilate, each point is going to move away from P in a straight line. What will be the distance from P to A prime if the scale factor is 3? Well, 1 times 3 is 3. Draw A prime 3 units from P. What will be the distance from P to B prime if the scale factor is 3? 1 times 3 is 3. Draw B prime 3 units from P. What is the distance from P to C prime if the scale factor is 3? 2 times 3 is 6. Draw C prime 6 units from P. Now I can connect my points to make my new triangle. Now you try a couple. Draw the dilation of ABCD with a center of dilation at B and a scale factor of 3. Go ahead and answer the questions on the right. What is the length of BC, the length of DC, and the length of AD? The length of BC is 2, the length of DC is 3, and the length of AD is 2. In my dilated figure, what will be the length of B prime C prime, C prime D prime, and A prime D prime? B prime C prime will be 6 units long, C prime D prime will be 9 units long, and A prime D prime will be 6 units long. So the 2 vertical sides of the rectangle will be 6 units long, and the 2 horizontal sides will be 9 units. Remember that when I dilate from point B, the points increase their distance from B on straight lines. So I can draw B prime C prime 6 units from B. 1, 2, 3, 4, 5, 6 to label C prime. I know that C prime D prime will be 9 units long. And I know that B prime A prime will also be 9 units long. I can connect my points to finish my dilated shape. Now let's try one last example. Draw a dilation of ABCD with a scale factor of 2 and a center of dilation C. Try to do this one on your own. Remember, each point is going to expand away from C on straight lines. Remember that each side will be 2 times as long because the scale factor is 2. Your shape should look like mine. The 2 horizontal sides should be 6 units long. The 2 vertical sides should be 10 units long. Go ahead and check your drawing with mine. You've done a great job on this video. Now it's time to move to practice. Go to tinyurl.com/practice912. It's also on the next page of your packet.